So today we're talking to Steve Kromer. He's been here before. This is his third time, I believe. Steve and I have known each other for basically my whole career in M&V, and I don't know how long that is. So it's a long time, maybe 20, 25 years or something like that. Yeah, I'll do a really quick intro. He used to work at, I think, the Lawrence Livermore National Labs, or maybe the Berkeley Labs, Berkeley, right? And Berkeley Labs, and he was doing a lot of measurements, and I guess he'll tell you that. I think he's going to tell you all about that. But anyway, he was instrumental in starting the first IPMVP, which was called the CMVP, and he's been involved with EVO and AEE all along for this whole, I don't know, last 20 years or so or whatever, involved in the whole M&V effort and all this stuff. So if anyone really knows everything, when I mean everything, it doesn't mean every technique. It means all the people involved. He's worked with them all. He knows a lot, and this will be actually a very fascinating discussion. I have no idea where we're going with this, so this is going to be pretty fun. That's it. Steve, let's see what you got.
All right, I'm going to go over to the other screens. I'm going to cut this camera off and see if this works. Turn this camera on so you can see me from here. But hopefully what you're seeing is the...
We do. It's working.
Yeah. Okay. Hi, everyone. As John said, my name is Steve Kromer, and John's invited me back because John and I have a really great professional relationship where we don't agree on everything, and sometimes we don't agree on really important stuff. But we're a model for moving forward. John's asked me to do an update, basically because there's been stuff moving in the markets. And John, please jump in with specific questions. I know you had some things you wanted to go over. What I want to do is just bracket, M&V, so quote unquote M&V, because as things are changing right now and the future is rapidly hitting us, these tools, these techniques, the definitions, the certification, the global approach to the quantification of the impacts of energy management projects, trying to be very general there. This is all changing in real time. So what we're going to do is just kind of do a little blast from the past, I hope, a little bit where are we, and then a little bit of where are we going. And hopefully I have a lot of questions and discussion along the way. Welcome to the 92 attendees, and hopefully we'll get even some more wherever you are around the world. Yeah, that's one thing. People are all over the world doing this stuff. So, the biggest fundamental first question is, what are we talking about? And I think I can confidently state that if you took any two people and tried to get them to write a definition for what M&V is, they would come up with slightly different things. And that's part of our core problem, which is that the general concept of using measurements for the purposes of assessing and quantifying the impacts of energy management, that's pretty straightforward. After that, everything's up for grabs. What measurements, how long, whether there's a model or not, what stipulation means, what to compare it to, all that stuff is usually lumped into this one term now, M&V, which actually was only first used in this context in the late 1980s. So right before the current generation of protocols was written in the early 90s, the word M&V kind of gelled as a general term for all this stuff. All right, so, again, for this audience and for John, we often like to think about primarily energy savings performance contracting because of the nature of Abraxas's business and the tools he sells. So yeah, role in financing and running projects, M&V is fairly straightforward. Yeah, energy projects leading to reduced energy consumption. Certainly reduced energy consumptions and have some value. The accumulated value can be used to pay back some loan, and the method of determining that is generally spoken as M&V. I'm going to play a little bit from something that happened in 1996, and it was the first download over satellite to 300 stations around the country, way pre-internet, of FEMP promoting the now just released NEMVP, the first version, the previous version from IPMVP. This little picture here is actually Steve Schiller, one of the big one of the other authors on this this thing. Actually, let me go back and do this one first.
Thank you for being with us today.
So this is a little bit broader background on the topic.
One of the most cutting-edge issues in federal energy projects is measurement and verification, or M&V. Energy savings performance contracts and utility incentives depend on proper measurement and verification of promised energy savings. But up until recently, there were no universal guidelines for measuring and verifying energy savings. All that's changed now with the publication of two very important documents which came out this spring. The first is the North American Measurement and Verification Protocol, or NEMVP. The NEMVP reflects the work of a large group of technical and industry experts commissioned by the Department of Energy to come up with universal M&V agreements for energy projects in both the commercial and public sectors.
The NEMVP is an industry consensus, common sense approach. How do you implement energy efficiency? How do you figure out what your energy usage is before you do the retrofits? How do you figure out what the energy usage is afterwards? And in between, how do you measure and verify to make sure that those savings persist? Would you ask
The second document, the FEMP Measurement and Verification Guideline, is the first official application of the NEMVP. The FEMP guideline was specifically designed for use in federal energy projects, including utility partnerships and ESPC. It also was published earlier this spring. Now that the FEMP M&V guideline is out, FEMP wants federal energy managers and their private sector partners to know all about it. In fact, on this very day at the NESCO conference in Kansas City, some of the authors of the NEMVP and the FEMP guideline are holding a workshop for NESCO members. The workshop is designed to introduce private sector companies to the M&V process and explain why it's so crucial to successful energy projects.
Over the last 10 years, the energy service industry has completed enough projects that we've actually been able to find commonalities among the projects and start to agree on how procedures should be done for measurement and verification. A remarkable thing has happened this year, and a wide range of industry experts have gotten together to form the North American Energy Measurement and Verification Protocol Committee, which has released this document last month.
The basis of this whole industry is getting data. It's getting a lot of information. The question people try to answer is who's using how much energy, for what purpose, by what time of day. If you can get a good, firm grasp on that information, then the answer of where are the opportunities, where can we save energy, where can we save dollars, falls out from that. That's the basis of this whole document.
During project implementation, measurement and verification is the single most important issue that is dealt with in these projects. That's why FEMP prepared the measurement and verification guidelines to work as a tool. And that's why we're here working today with the ESCO industry to implement this tool. Our goal is to make projects happen, and that's what FEMP M&V guidelines are for.
All right, so that's the first thing. What I want to highlight just in that little clip was an original kind of problem and distinction that came out when we wrote the protocol. You saw Larry Ringel, good guy, saying it's all about measurement and down to the time of day and time of use. If we can just measure everything, we'll be done. What he missed was all those measurements in M&V have to be put into a model so you have something to compare in the future. So I think it's really interesting to listen to that and go, one of the original problems was just that, people didn't understand that the measurement had to be combined with modeling. Here's me trying to explain this way back when.
One of the principal authors of the FEMP M&V guideline and a major player in the development of the NEMVP. He is Steve Kromer, energy engineer at DOE's Lawrence Berkeley National Laboratory in California, and he joins us live now from Kansas City. Thanks so much for being with us, Steve.
Thank you, Doris. Hi.
Hi. Now, for those of us who may still be confused, what's the relationship between the NEMVP and the FEMP and M&V guidelines?
The relationship is that, as you heard a little bit earlier from Greg Katz, about a little more than a year ago, NEMVP as a body was formed, a committee was started, DOE was the host along with EPA and others in Washington, and a number of groups were brought together under one committee, and a task was assigned to create a consensus document as much as possible with everybody included. That effort went forward, FEMP was a part of that, and around early into the effort, the ABCs and some of the structure of the document were formed. Along that time, FEMP also decided to go ahead with an application document, and that's what's come along with the FEMP document.
All right, I'm just going to pause there. I know you're all thrilled. The whole point being there that as we developed the first document, FEMP protocol was a performance contracting need, and these documents got thrown together, and FEMP came kind of out of the chutes first with its application guide for M&V. And remember, it was just ABCs then. We didn't have option D. All right, John, any comments on that? Besides the fact that I'm a dweeb?
Yeah, you look like a dweeb, but no, FEMP guidelines was great. I love FEMP guidelines. That's it. I got nothing else to say.
Well, I've got a longer version of this for anybody that wants to watch it up on YouTube. I'll give you a link later. You can watch the whole 6 minutes. And I'm actually trying to archive, get out of archives all the various videos that we did back in that era. I think they're pretty interesting now in terms of the formation of all these ideas. Okay, that's going back. And what happened then was, M&V moved forward from the original NEMVP to IPMVP, and we went into basically from the very beginning 2 different directions. And one was M&V applied in contracts, performance contracts, agreements between parties and stakeholders. That's a whole world where M&V is relevant and useful. The other one was over to the utility program side. And a lot of the original document had utility program people. And those things, though, have a greater emphasis on scientific, quote unquote, accuracy. They have relevance to commissions and government and regulations, and they want to know what happened when you run a program. So they bring in smart people that have PhDs on evaluation and statistics, and they run a whole different kind of thing. Now, the fundamental methods are the same, and that's what we'll get to. Okay, the purpose for contracts, of course, is a set of rules that parties can agree to. All contractual terms are considered. And in a contract, you have to worry about who's maintaining the ECM, ESM, EEM, whatever it is. What's the effective useful life of the piece of equipment? Who's going to replace it? There's all these things in a contract that are fundamental to the operation of the facility that have to be thought about. And they all create risk and responsibility terms. So M&V for contracts is full of this subtext, full of things that affects the quote unquote savings and how it's defined. For instance, if the owner goes in and turns off the lights for a week, is that savings or not? That has to be defined in a contract. In programs and research, that's all kind of washed out, the responsibilities. So they just want to know, if we do this program on 10 buildings, what's the likely return? And things like the owner turning off the lights, factors into the number, but they don't really do a responsibility for it. So the primary purpose of program research is to assess the effectiveness of the retrofit for a program. They do it at one site and in general. Often involves sampling. So you take a sample of projects and you look at them more deeply, and utilizes larger budgets, allowing a lot more, closer look at what's going on. But they also bring in all these other terminologies like code baseline, dual baseline, what would happen if we hadn't been there, if code had changed, stuff like that. It's not usually in a contract. All right, so all we're saying at this thing early on is M&V developed in a world where there was a great need at the federal level to generate standards about how to use measurements to support these huge programs. And no one quite got the fact that when we put the ABCs together, it also included this thing called modeling. It was more a measurement and verification protocol, but it was actually also counterfactual modeling. ASHRAE adopted the same techniques, ISO later adopted the same techniques, and they also, by nature then, had to include the counterfactual argument, which is what would have happened if we hadn't done the project, and how do we build a model or come up with a hypothetical for that comparison. Okay, just again, fundamentals of M&V. There's usually a design already, every building out there's been designed, constructed, and it's somewhere in the operation phase, typically when M&V comes in. So, M&V's also got to think about what was the purpose of this building, what are the standards it's trying to meet. A lot of other things are involved. Let's go with the 2 main methods. So right now we're in 2022, and we have a number of protocols out there. And what we're revealing in recent times is, the core method of options B and C and D is establishing a model that you can use in the future to compare to what actually happens. And that's called the counterfactual method. We didn't invent that. You can look that up. You can do research. And I started a company called Counterfactual Designs based on that concept. The origin story of that concept comes from talking to someone who does research in resource agriculture economics and saying, oh, you just design your own counterfactual for every project. And I went, bingo. If you understand that, a researcher at Cal the method we're using, that's a way of communicating this to the greater world. It's really easy. So maybe in engineering and IPMVP in our world, we haven't used that term, but what we're trying to do, what I'm trying to do is broaden the number of people that can play in this space to everyone who basically understands the game. And that's a lot of people that are outside our current industry. So the counterfactual method to me is really important to say, hey, if you get what that is, now we can play this game more efficiently. And that includes regulators, financiers, everyone involved in the whole energy efficiency space. They have to understand what the counterfactual method is. The other one's the one most people think about. It's just to go take measurements on a system and see if it's working, quote unquote, properly. Performance measurement will always be out there. And actually in the future, when we get to net zero, you know, the long-term measurement and assessment of a facility will just be, are you net zero or not? We won't really need the counterfactual method in the future, is the way I look at it. This could be argued, John, in a future seminar. But I think the counterfactual method has a half-life of about 10 years, which means it ought to last about 20 or 30 years before we're just measuring net zero across the board. That's for another argument. But these are the two main methods that M&V really is based on. And you've seen this one a million times, the classic what would have happened, the red dotted line there. That line is impossible to measure. It's the creation used from the counterfactual method. It's only as good as the two parties that have to agree to it, or however many parties. It's only as good as their trust in each other and the method to develop it. Everything else is up for grabs. The black dotted line, sure, easy. You just measure that. That's not a problem. All right, then, we adopted this counterfactual method without, screaming from the hilltops. What we didn't adopt at the original time was the control group, cross-sectional benchmarking. There's a number of different terms for that. So just remember, when you're doing before and after, you can compare yourself to yourself over time, longitudinal benchmarking, but you can also compare yourself to a control group or a comparison group of others. And that's coming in now. So we're going to get to the future later. That's becoming really important in these flex markets and other uses for quote unquote M&V. So comparing yourself to yourself over time has been our primary method. We're going to have to evolve into also comparing to others and using randomized control trials and other types of control group thinking. And then finally, things that M&V really hasn't thought about in terms of IPMVP protocols and contracts was these other terms like what's going on in the market. Can you even buy an old chiller anymore? So if you can't, why would you credit someone with purchasing the new one? What's the effective useful life? All these things that get drawn into utility programs probably should have a role in all contracts going forward. All right, so that's kind of where we're at. The main a little window into the future here is this complex of 6 interrelated uses on the grid. So anyone who's paying any attention to the news sees that grid optimization and just grid reliability, keeping the lights on, is becoming really important. And all these 6 boxes have a role in that. So demand response has become actually called flexibility now. Electric vehicles have a big role. Wind comes and goes. Grid optimization. You can read all those for yourself. Anyway, that's sort of where things are going. Backing up a little bit, option C software, classic M&V. We used a limited number of data points and tried to use this quote unquote frequentist method of statistics to do what is basically econometrics, which is to identify if there's a driver that explains the variability in our energy use. And if we can find that driver, which in this case is heating degree days, we can construct a model, and we use that model in the future to compare to what actually happens. Okay, that's pretty standard. One complication that's happening with hourly methods is now we have 8760 data points, not 12 for an hourly. So we get splotches off to the right, or really complex things like the upper right there. When you have 8760, you've got what I call big data because you can't conjure it in your brain at one time. And someone looks at that and says, how many models do you see in this data? Well, in the modern world, someone says, I can see at least this many. For every hour of the day, there might be a different model. And that model might have 2 or 3 lines. So there's a kind of complexity that's coming with hourly data that may bring more accuracy. It definitely brings more complexity. And just to throw it out there, if John Shonder's in the crowd or anybody else, the way we've been building models up to now typically has been using this method called frequentist, and you can look that up or we can talk about it later, John. But it's not the only way of getting the parameters for a regression model or any other type of model. And the thinking around this has changed generally in the statistics world. I was on a bike ride again this last weekend with an astrophysicist, and he said, "Oh yeah, in our department we're having debates about frequentist versus Bayesian." So, here's the future coming at us. You have to understand, or you want to understand, if you're interested in the future of M&V, you're going to want to understand what that means. You're going to want to understand what frequentist versus Bayesian means, and why all of the international statistical bodies are actually having discussions about this right now. So I just threw this slide in as a placeholder for the future and the folks that are having this discussion. And we'll hopefully talk about this later. That's one end of the spectrum on modeling. Let's just give an actual reality check though. And this is something that came in from the Navy. Dan Magro went to one of my early seminars in 2000, and he laughed because I told a joke about how the M&V engineer from an ESCO can always tell you they saved something, because no matter what happens after you're gone, they'll prove they saved something. I forget the joke. Okay, sorry, I'm not a good joke teller. But he remembered that joke, and he said, what we've learned at the Navy over the last 20 years and running this, and this is his presentation, is that trying to run models isn't working for the Navy. There's too many changes going on in their projects. Trying to do non-routine event adjustments just isn't working. The way the government task orders are set up allowed too much flexibility, so to speak, for the contractors to try and make change orders. So they just usually do not allow models anymore, and they look at performance and quantify performance over time, take snapshots, and then they calculate savings based on that. It sounds a lot like option A, actually. And they also don't stipulate savings, which is, of course, no measurement at all. So I'm just saying, in the real world, as these protocols have rolled out, there are these there's a spectrum of application. And one is, there's a big program where they're not even using models or the counterfactual method. They've reverted to performance measurements. And then on the other end, you got those Bayesian folks. M&V experience, John, you're familiar with this. In KSA, in the Kingdom of Saudi Arabia, they've got a huge program going. A lot of projects, and it's 5 years in, and they've actually got their own M&V guide, and we're hopefully going to adapt that a little bit based on, again, the standard definitions. But it's been a learning curve for everyone involved about what it really takes to operate, the counterfactual method in complex situations, and the cost to do that, and the requirements. So there's a learning curve in applying the M&V protocols in these big programs. A lot of people are coming up to speed on. So what I've claimed all along is the best defense for M&V to be useful in the real world and to make the kind of satisfying decisions you got to make on a project by project basis is to have both sides of or all the parties involved to truly understand the issues and come to adult decisions in contracts about what to do. And this is where John wanted me to talk a little bit about the evolution of the certification regime. So if the real answer to M&V is not protocols, because they're very general and can't ever get to the level of specificity to handle individual projects, then we need people that can walk into a site, walk into a situation, and come up with a good enough M&V strategy for each project and have both sides agree, because they understand the limitations of M&V. And the protocols have been written. 20 years ago, the CMVP program was set out. For 20 years, it was primarily based around the IPMVP and EVO's committees. As of earlier this year, that relationship ended, and there's now a second set of certifications from EVO itself called the PMVA and PMVE. John, do you have any specific questions on that you wanted me to elaborate on, or?
No, I think everyone knows. I mean, there's a lot of CMVPs that are online, and I think they understand, they still got a CMVP, but they didn't get grandfathered into the PMVA or PMVE, right? They still have to go and take a class and take a test to get those. Do you know that?
I'm not qualified to answer that. My understanding was that if you are a CMVP, you would just apply to EVO, and they would grant you a PMVA at this point. I don't know what the the terms of the length of your certification are, whether it's for a year or two, or, whenever you paid up for CMVP, I don't know.
Oh, wait, we got a note right here. It says the CMVP was granted a PMVA. Okay, so there you go.
Cool. The thing I can say unequivocally as well is the CMVP was needed to create new materials. So we went through a process this last year, starting in January, and we did a job task analysis. This is all backed by AEE and their commitment to the CMVP program after 20 years. So we did a job task analysis, a formal review with 9 experts from around the world on what should a modern CMVP know, what's evolved. And we went through that. Then based on that, we hired a team of international experts and we generated new training materials for the CMVP. So the new CMVP has a new direction, a broader base of information and different direction for the future. And so there is that distinction I can clearly communicate. Beyond that, I guess I can't talk about, the Evo stuff. I think it's still the same course we taught for the last 10 years, more or less. So that's okay. The past, we put this stuff together. As John said, I was involved. I was along for the ride. I was a project manager from LBL, watching all this come together. I've been watching it for 20 years evolve in terms of CMVP. But what's hitting now, really based on the success of these methods. It's strangely enough, in a weird way, because the counterfactual method, people didn't really understand that's what M&V was. A lot of people, and but it worked well enough, these protocols, to get us to where we are now having to face a whole changing world in this thing called the energy transition. And we have things like in the middle of the day that power prices are going negative, and they're volatile anyway, for sure, across the country, especially in the big markets like Texas and California. And we have a number of different distributed energy resources, PVs, EVs, that whole grid I showed you earlier coming in. These things are upending the viability of the counterfactual method. And why do I say that? It's because counterfactual method is based on there being a stable baseline that is a fair and relevant comparator in the future, so that when the future happens, you've got something to compare to say what would have happened. Well, if you don't have a stable baseline, you've got very little basis to claim exactly what would have happened, or at least you have to change that basis. You can't just take the last 12 months and say, here's what would have happened. So we're seeing a big, a fly in the ointment, or a challenge to our counterfactual method, basically. I just threw in some very, very recent slides. It's from yesterday, that are actually upending a lot of thought around all this. So here's Greg Dixon, who, if started Voltus. He was Internoc before that. What I find most fascinating about Bitcoin, other than obvious promises of digital currency, is that it drives the growth of renewable energy, offering a grid balancing mechanism unlike anything seen before. Like it or not, or believe it or not, what he's saying is the grid is getting to a point where when all these renewables come on, sometimes they flood the grid. You need big loads available to use that extra energy, or else it bollocks things up. So miners are a potential solution. They generate value from that otherwise wasted energy, basically. Of course, there's also storage, but that's a whole other world, right? Anyway, this is where we're headed. Is Bitcoin coming to the rescue of our world? All right. No matter what the rescue is, what we really know for sure is that the monthly models are not going to be able to handle these kind of day-to-day, hour-to-hour changes. So interval data models and simulations are going to be needed to allow efficiency to play in this new world. Again, I'm back to energy management and efficiency, or conservation, whatever one of those terms you want to use. But for those of us that have spent our entire careers trying to get the same with less energy in, right? Get the same cold beer, warm shower, nice house, dry, quiet, whatever, cool, warm, whenever we want to use energy services, and we think we can deliver them better as engineers, we've got to prove that differently in a coming market. So if we want to play in that market, we've really got to up our game in order to play it. Savings need to be demonstrated. Yeah.
So I don't know if, what your statement is that you said is, everything's all changing. We have the duck curve. There's different, charges of power, different hours of the day now. It's all changing and all of that. And therefore we need to change. But I think the we all of a sudden gets a little more complicated, because there's two different we's here. The utility people, yeah, I think they need to change, and they are changing. But the ESCO people, I'm not so sure about that. I'm not so sure that this is in their future. I mean, there's value in interval data models. There's no question about it. But the question is that somewhere that they need to go in M&V, or that they will eventually be doing? And I'm not really convinced of that.
All right, so John, we're going to get through this, and let's get that back to the end again. Let me get through the presentation if I can. But the main thing I think that everyone has to address is the value side, like what people are being charged for energy at what hour of the day. That's going to become more and more important. And let me give a few more examples, then we can have this discussion with what you just brought up later. So hold that point, okay? What we know for sure is things are changing, and both sides are probably going to have to relate to the value side. Again, there's negative prices in the middle of the day. Here's another thing we know for sure: whether or not the ESCOs in their classic business model want to play in this game. But there's this thing called Flex Market now. Market Access Program in California is up and running. There's other ones coming around the country. There's interest all over the world. And again, this is a success story for M&V. It's a whole facility method where you collect baseline data for a year of hourly data, and you compare to 1 year in the post period in most of the M&V constructs. I know this is a very it's still new, and so we're changing these rules are changing in real time. But basically, you look at the load shape from before and after and compare the two, which is M&V, counterfactual method, and there's an hourly savings rate that's generated in the program. And at the peak, you can save up to $2 a kilowatt hour at the peak times. So all this shows, again, that M&V has been successful enough to get integrated into a modern program. And the whole goal of this is to reward people for shifting their peak loads, so it relieves the grid of overload from at certain times, and rewards you for moving the load to where the grid really wants to have it, which is when all those renewables are on. So flexibility is happening. There's no question about that, and there's big financial incentives behind it. Here's 3 links I put up. I'm not going to be able to open. Let's see if I can. Yeah, good. This works. Okay, so. For those of you that get these slides later, you can come back, but turning buildings into virtual power plants is the whole idea here. The Flex Market helps you do that. If you want to go talk to other people about it, you can go to the FlexCon. There's a whole conference in Europe, and look at their sponsors and look at the amount of interest in this technique of, it's not long-term energy conservation or energy efficiency by putting new light bulbs in. It's a little bit of that and a lot of how do I shift load? How do I use storage and other techniques? And then finally, if you want to see what's going on around the country, you can sign up for the DOE's mailing list. But Energy Markets and Policy has state indicators for where this is going and a really nice interactive map for programs across the country. This is the future of a large number of utility programs. And I think M&V people need to be aware of it, or want to be aware, because you want to be able to play. Okay, this is the second slide I cut and pasted, sorry. But again, it just means that there's more need for educated people across all these markets to understand all these techniques and these new tools and these new programs. And we're dedicated on the CMVP to raising professional standards to include these new programs when you get your CMVP. You want to be able to quantify energy use impacts across all these types of programs, and this training goals are to get you certified, get you through the examination. Again, this is just a little sales for the CMVP, or at least explanation. These are some of where we've changed and where we emphasize what the fundamental methods are in M&V, how it goes together, what are and we emphasize in this new course that the first thing you do as an M&V professional is identify your context. Am I doing a classic performance contract, or am I in a market access program, strategic energy measurement? All these have different M&V requirements, and those requirements are being rewritten as we speak. That's the important thing a new CMVP needs to know, so they can go focus their efforts on their specific context and understand it. Again, I'll go through this for the interest of time. You can read that later. Same with this. This is just the role of the CMVP in the modern world. Job titles. Okay, these are all the types of people we're trying to get through the program. All right, no matter what we're seeing is a proliferation of types of programs, types of M&V strategies, and underneath in the actual facilities, data. So here's the thing from yesterday, where there's been a new rule released in the vehicle Vehicle Grid Integration Council, where parking your car, you don't even need to go to the meter anymore. You can get credit for back and forth power changing from your car. This is complicating the baseline, right? California's sub-metering decision, a game changer for these types of solutions. So in real time, our nice old stable baselines are being upended. And another one I got from just today off of Twitter, more emphasis on the types of data that are available in sub-metering, detailed sub-metering that can be useful in granular data for supporting energy projects. All right, so to finish, energy efficiency thinking is outdated. This is another Twitter. This came from yesterday. The old thinking from this person for the first decade was that you can save some percentage of your utility costs on annual kilowatt hours and therms. You could measure energy use intensity with an EUI. You can get Energy Star certified, to see you benchmarked. You go for the utility incentive applications to help your project survive, but you're really blind to the outside world. You assume a safe and standard and stable generation, transmission, utility regulated, giving you a price signal. And you do your hard work, but you're insulated from the complexities of the grid. What we're going to is the business value of meeting your carbon commitment. So when are you saving energy? That's going to impact your carbon commitment. Hourly kilowatt and conversion need to be to electrified heating. There's going to be electrification going on. How does dual fuel stuff hit you? Carbon intensity measurement and reporting is important. You want to try and become 24/7 carbon free. You can now get paid big incentives for being flexible, so moving your loads. You can have the same load, you just have to move it back and forth. Behind the meter and beyond the meter are one system, so it's connected, and local DERs, distributed energy resources, all these things are playing together. So these are they're bundled and simple to buy, but they're definitely complicating our world. So to conclude, M&V has been a great career. It's a great way to help energy efficiency play in the world of ideas and money to do projects. It was based on counterfactual methods and performance measurements. But what about the future? Are those really going to be good enough? That's the kind of discussion I want to have. The existing protocols have been good, but we need new ideas and new words on paper called protocols to guide us all through how we're going to manage this transition to a really complex system. And not just the engineers on this call, and hopefully there's some non-engineers, but everyone out there needs to be communicating these concepts. That's the regulators, the financiers, everyone in the food chain that supports this industry has to truly understand how they're doing their accounting, how we're accounting for our value. So we need to actually expand that whole community of experts. And that's my goal. This Counterfactual Designs is my website that we posted a few months ago. I intend to have it both as an entertainment channel with, yes, everyone's got a podcast, so I'll have mine. But we hope to have, to some degree, these types of discussions that we're having, John, you let me do here. Maybe we can post some of these up here, a YouTube channel, but more training, access to things like the Bayesian research, access to cutting edge, and opening up M&V to a wide range of experts around the world. Here's, I guess, my last point. The community of experts needs to be expanded. And by that, I mean, if you go to do research on Bayesian methods, you'll find people in University of Texas, Michael Perch, with a fantastic set of resources that are all relevant to our industry in terms of the toolkit. He's doing it for geostatistics, for oils, really. The same thing happens with an evolutionary biologist named Richard McElreath in Geneva right now. He's got a great set of tools that allow us to do all of our techniques that aren't in energy efficiency, but could be. So my goal is to make sure that world of experts around the world understand that they could contribute to the energy transition as well. We probably need them, and they should all become part of the larger family. So with that, I'm done, John, and we can go to questions or comments or discussions.
Yeah, I wanted to, I don't know if hey, Tyler, are you out there? I sure hope he is.
Yeah, I'm here.
Okay. I wanted to have maybe some input from, I know this is kind of bad, but I'm going to name a few names, and if one of you wants to speak, I would love to hear what you have to say. So I'm going to name a few names. So like Karen Mann, Marco Clerks, Brian Klippinger, Christy Michelle, and one other guy, I forgot his name. Anyway, I guess I'm not going to see it fast enough. So if one of you would like to speak, please write down in the question box that, yes, let me talk, because I want to hear what you have to say about the future, because everything he said is right. I mean, everything he said is true. You know, everything is changing, and the utility programs are taking all that into account. There's no question about it. But the question is that something really the ESCOs are taking into account or will need to? Maybe in California, maybe that's something that's going to happen, but in Idaho, maybe not. And that's what I would like to know is, are you guys thinking about this? I'm going to see if anyone.
Those people or anybody that John didn't name want to speak, just go ahead and raise your hand, and then I will know to unmute you if that's what you want.
But I'd prefer to have the ESCO people speak, because I already know that the utility folks are doing this. We know that. There's no question about that. Okay, it looks like we got Lionel. Let's see, is he going to say something? Let's see, Lionel's written, the ESCOs will be difficult to move. What about the circa 2001 NASCO white paper, which specifically promoted pre-post measured and stipulated savings instead of actual measured results? ESCOs don't want to take any risks in spite of how they market themselves. Well, yeah, true. I don't know, so I haven't heard anyone say that they are willing to speak. So if they're not, well, if they still are, we'll hear from them in a minute. But Steve, do you want to respond to what Lionel just said?
Yeah, I think I don't want to give the impression that the existing ESCO market is dead, so to speak. Actually, let me see if I can go back and change my camera here a little bit. I think you've got a half-life there too, where you know, the traditional methods are going to be around for quite a while, and in certain markets, that's where you'll play. I think they're pretty well vetted. The rules are there, the techniques are there. We might add a little bit with John Chandler's on. He can talk about how his Bayesian models will generate that coefficient.
I'm going to ask him to do another webinar, so we'll just do a whole webinar
right
on that.
I mean, we can say, you know, the Bayesian methods can generate the coefficients as equally as frequentist, and they give you a better confidence interval. Okay, that might be important or not for that market. Who knows? And that's good, because there's, you know, you can, like anything out there, there's people that you need people running COBOL right now, right? There's ads for, if you can do COBOL processing. And I'm not saying that's bad at all, it's great. But that's not where the leading edge of the world is. Now, if you go to that Flex Market site, what you're gonna see is the number of aggregators that are out there, and these guys are putting together, working with industry partners. It's like the modern ESCO. The play is a one-year play to move the load around. But you're going into a facility, assessing what you can do, in terms of both reducing energy and shifting load, and then enrolling in a program and getting paid a lot of money to do it. So it's a very fast, efficient ESCO market. It's just not what you're used to. And again,
that might be the new LEDs. You know, maybe that's what it's going to be, because you know everybody's already done LEDs, so now we need to find something else.
Absolutely. And the whole thing, the story here I'm trying to tell is that the protocols when we wrote them were good for what we wrote them for. And in 1994, we needed a big program in the FEMP program to take a slow-moving, you know, beast called the FEMP, you know, the federal government, and bring capital in. It's actually a pretty interesting watch, that whole telefemp thing. It was new and innovative to bring in outside capital to improve federal facilities. But we see how that played out in the Navy. It was just too complex to really run those protocols the way we kind of envision them, so they went to option A almost entirely.
Right.
You know, and the counterfactual method, though, that's the basis for the new tools, which is the flexibility. So there's like numerous threads to this story that are really interesting, but we just don't have a modern protocol that covers them all in one place yet.
So Marco Clerks will speak. Tyler, can you put Marco on? So Marco is he's in charge of M&V, I think in the East region at Honeywell. I hope it was not wrong for me to out him like that. He's been doing this as long as I have. He's probably our age, and he's seen a million projects. So he's seen a lot, and he's very smart. So let's hear what he has to say. Tyler, can you get him on?
Maybe he's having audio issues. It says he's unmuted, and
that's too bad.
Yeah,
that's too bad. Okay, well, maybe, Marco, keep trying to talk and just interrupt us. But so let's say we're doing Idaho. I don't know too much about Idaho, but what I remember was Idaho was really simple. Idaho Power was, and they're not like California, which is really complicated. I'm sure New York is too. But in Idaho, you're not going to see this. It's still going to be old school, but you're saying in these more modern, let's say, states with these modern utility programs and all of that, and utilities, this may be another way of saving energy, or not saving energy, saving money for the clients, and to do it by moving demand around or moving when they're using energy and all of that. And then for that, you will need these newer tools like interval data.
So John, the way I'd respond to that is for those economies or those parts of the grid, so to speak, where renewables have become a big proportion of the power being delivered to the grid, they've changed the whole economics. They've changed the whole delivery mechanism, the stability, all that's changed. So what you know, if you want to find the old world of ESCOs, you go to somewhere where they've got a bunch of coal plants they haven't turned off. They run them all the time, or some nukes, and they're just running stable at 4 or 5 cents a kilowatt hour. But if you come to where we've put this decarbonization as a major goal, and renewable energy as a major way of getting decarbonization, whether intentionally, it wasn't intentional, but it was known issue from day one, is you're going to upset the delivery of those electrons. And that's going to cause all kinds of issues within the ISO, the independent system operator. That's going to create opportunities, financial opportunities for balancing all that out locally and regionally. So the idea that you could run again, what happened this last year in California was a $150 million pilot program, which is underway, called the Market Access Program. And it's here, the regulator, put their foot down, or where they made their statement that they want demand flexibility as a major proportion of all the energy efficiency programs. It's taken a big chunk of the budget, and they think that's important because it's going to address the reliability issue with the grid, with the renewables. But so is Bitcoin. You just can't make this stuff up. You got delivered, demand response, and then you've got also people putting loads on, timing those loads to make useful. Someone could have a mining operation as part of their energy program. Who thought of that, right? I mean,
or they could use that energy to produce hydrogen as well.
That's true, for storage.
So I got one note from an ESCO person. He said, we can do an hour level analysis, but is the cost worth it? So is it that much, more expensive to be doing this, to be modeling hourly as opposed to just monthly? And I guess it could be worth it depending on the ECMs, right? If you're in California and you really are shifting load, yeah, it's certainly worth it. But if you, I guess if that's not part of your plan, then I guess it isn't.
It's all part of your price, where your price signal is. If you got real-time pricing, which is coming a lot of places, then it really depends when you save the energy. Then you want to know your load shape. You have to know your load shape. And if that's what you're doing, you need a simulation model up front to show to predict how you're going to affect your load shape. Right? That having the statistical data is not going to be enough unless you got, or sub-metering, right? Hence all that world of sub-metering and all those folks that provide a lot more data about your facility.
You should be able to hear me now.
Oh, we do.
I was muted by the organizer.
Yeah, that's Tyler's work. All right, talk to us.
Hi, John. Hi, Steve.
Hi.
Hey, so one thing I'm really glad to hear that you said about this still lasting for another 10 years or so, because some of us want to keep working in the same field we understand until we retire. The other thing is, if you notice, like ASHRAE and a lot of codes, it seems like it takes 10 years before people have been trained to actually take the new stuff on. Like ASHRAE says, don't use degree days, and yet here we are today still using degree days. But one of the things in terms of ESCOs, so John, you have to think about some of these large companies that have ESCOs, of which I'm one of them. They're actually walking the dual path between, there's a group of us still using still addressing the standard performance contracting method. Then there's a whole nother group of data scientists that are developing tools that to address the arenas that Steve is talking about. And even within our own companies, we have this conflict of, our mental pictures of what M&V and what the arenas look like. And so, like, I just asked a lot of them to join this call because I keep telling them, I keep saying, look, you're in the middle of an evolution change. It's going to be hard to understand what's going on in the future. And Steve, is there anything you can do to help us? Because, now we, large ESCOs or companies that have ESCOs also developing stuff. I mean, how do those groups of data scientists and other people stay in tune with this new upcoming world versus the standard ESCO method?
Marco, I didn't plant that question, but that is, I have two answers. And I mean, I fired up counterfactual designs because I believe the world needs a place to have that conversation. And it's both one of my advisors financially, fiscally, just to create this company, said, are you an entertainment? Do you want this to be an entertainment company? Basically, because do you want to just do podcasts and YouTubes and education type stuff? Or, actually, it's like, Michael Lewis is here. He's an author. He has a great podcast called Against the Rules. That's one of my models. The other is Nate Silver, the 538 site. He has a thing called Model Talk. And what I want to do partially is, again, have part of my counterfactual designs be that kind of thing, where I want to interview people around the world, which again is a recent development where I can pick up my Zoom call. And maybe we already have people all around the world right now. We probably do. And John knows I work in Saudi Arabia. John knows I work in Australia because we've met there. I work in China. We have a great new CMVP partner there. This is global. It's a global discussion we're having now immediately. So I want to make a place for that. And that's what we want to do. And then second, I think expanding, maybe you're scared of Bayesian modeling, but I guarantee if you're near a university town, there's a couple hundred people that are doing this right now. They're doing it for machine learning and AI type stuff. But they're doing this modeling, and it would be really easy to plug them into energy. We just need to make awareness. And so it's the other angle on our counterfactual designs is linking professional communities and educational academic communities around the world so we can share our modeling expertise. Those are the two things right now. Yeah.
So my takeaway from that is either call up Steve Kromer and ask him questions, or
sign up to the site. It's on the next. Is it on the next page or the last page?
But I'm just joking. Or go to the university. So for the group that's doing the larger data sets, go learn about Bayesian statistics. But those that are working in the ESCO world, you're basically going to be sticking with the ordinary least squares method type of statistics for regular performance contracting.
Yeah, there's a whole thing there where keep it simple, do the least amount and do what makes sense. I tried to emphasize earlier that, the best case is where all the parties involved understand and agree, right? That's from day one. Like your clients should have CMVPs on their staff, and they should know that that's probably the best method if that's the context you're in, right? If you're doing a standard performance contract where rates are fairly steady, that's really cheap and easy to implement, that's a great method, It's the universal screwdriver type thing. But there's also regular power drills and new fancy, laser type tools. And you've got to, you have a big company, you can figure that out across your departments, although you have trouble, I know, challenges there. But yeah, they're both valid methods. They will be valid methods for a while.
Well, there's one other thing, and that's, so M&V is, one of those statements said, the customer believes in it. You need a certain amount of transparency and trust. Mm-hmm. And sometimes in all the statistics talk, you tend to forget that sometimes you have to present to a board that's a lawyer, a housewife,
that's right.
Regular person, and it's hard to explain it to them. And I often tell people, so back in the 80s or late 70s, you had GIGO or whatever you want to call it, garbage in, garbage out. Everybody was arguing about whether or not to believe these computer printouts. In my mind, maybe because of my age, I think we're in a new world of of garbage in, garbage out. In terms of, just because I have something that says it's AI and machine learning, do I really have to trust that 100%? Because it has a certain amount of uncertainty, but they never seem to declare what that uncertainty is.
So I made on my third bullet in my conclusion, Marco, that everyone involved needs to be informed as these methods adapt. So again, the CMVP certification is one way through AEE to communicate to a global network of people what the basis is for setting up methods of quantifying impacts, right? And there's a range, and it's really important what context, but everyone involved, we put a great emphasis on the CMVP on assuring that you have the big four, the commercial interests involved, the legal interests, the political, and the technical. We look at M&V as a set of mechanisms that need to be understood by everyone. I totally agree. That's going to require, again, on our entertainment channel, a different level of discussion for different people. It should all be universally targeted, right, to the techniques. But some of these YouTubes and podcasts will be with regulators and what they need to hear to get their, what they need to hear from NARUC. Same thing with, financiers, how they want to portray it. So that's our job for the next 5-10 years, right? Is to bring the community together.
It's been interesting. We probably should stop. It's 11. Marco, do you have any last points? I really appreciate you coming on.
No, I just thank you. Thank you very much.
Okay. Steve, this was really good. So I love it when the last two webinars, this one and Lonnie's on the EVs, have turned me, and I love it when people are able to change the way I think. I love it. And so nice job. Well done.